Hi, my name is Riya Chaudhary, and this is my team.
Hi guys, I'm Erica.
Hi, I'm Taken.
And we have two more members. They are giving small video clip of their presentation because they are not here. So this in past, like we did different projects similar to like our project EEG and QAG, but this time we are doing EEKG, which includes different 3 monitors. Our project is the impact of visual aids on memory skill throughout qualitative survey and quantitative data analyzing. So for this project, we are using 3 monitors. First one is EEG, which measure brain waves of frequency. Second one is EKG, which monitors heart rates and cardiac cycle, and the third one is GSR, which see how when you visually see some videos or like scary part, how it impacts on your body and how much you sweat, and we can see by monitoring this 3 stuff in human bodies. And the next one, our team member T is going to explain the QEG.
Have the video separately used.
Measures the electrical activity of the heartbeat. If you look at the image on the slideshow, you're going to see the P wave, the QRS complex, and the T wave.
I just leave it playing on the other side because it might. Okay.
The electrocardiogram test that measures the
Sorry.
Stop touching it.
activity of the heartbeat. If you look at the image on the slideshow, you're going to see the P wave, the QRS complex, and the T wave. The P wave is the atrial contraction. The QRS complex is the ventricular contraction, and the T wave is the ventricular relaxation. We'll be using the BioPack system in our research to monitor the heart rate of the pulse participants to see if there's any reaction to the visual aid we'll be introducing to them. We hope to find that there's a correlation between the quantitative data we obtain from the ECGs or the EKGs to the memory skills given to the participants during the pulse survey. Activity of the heartbeat.
And this is Sarah talking about the EEG.
Hi, I'm Sarah. Sorry I couldn't make it. I'm here to discuss the EEG portion of our research. An EEG measures the electrical activity at the surface of the brain in waveform in terms of frequency. We will be using an electrode cap which will record this activity. The electrodes on the cap will detect the wave patterns. There are 5 specific brain waves, most having a high and a low amplitude. Gamma is associated with a really heightened awareness. It's very hard to achieve high gamma. High beta is when we are in high focus, like when we're learning and taking an exam. Low beta is when we are paying attention and engaged. High alpha is when we are relaxed, still paying attention, still like in a movie theater. Low alpha is when you are relaxed and you become very sleepy. Theta is when you become sleepy but you're still awake, and delta is the deepest sleep. What we want to measure during our research is what is the brain doing? Hoping to see a spike or a change in the frequency when we are showing the video clip.
Alright guys, so now we're going to be talking about the sample results of the EEG and how the brain scans look like. So if we take as an example the gamma ray Ria showed. So for example, Yeah, that's the cap that we're going to be using. But so for the gamma ray, we see that where the warm colors are, so the red and the orange, that's where the higher activity in the brain is located on. And then where we see the blue and the green, that the cooler colors, that means that the activity is not as high as in the frontal lobe. Now in this picture we see the setup of the equipment that we're going to be using. This is the BioPack, which is that blue box over there. And then the cap is gonna be connected to the BioPack, and then the BioPack connected to the computer, and then we're gonna be reading the brain waves like that. But also we want to add the electrodes into our ankles and our right wrist, and the electrodes also in our fingers, so we can read our heart pulse like Ria said. And then this is a quick look in our experiment. So it's going to be divided into 4 forms: the consent form, the experiment itself, the pre and the post survey. Now for the consent form, it just allows us to perform the test, and it also broadens the understanding for the participants, so they understand what the test will be like. Now the experiment, what we want to do is to show a set of videos to the participant, and then we're gonna record their reactions using the BioPack. Now for the pre-survey, we're gonna be asking a set of questions in order for us to acknowledge some variables that we want to disregard, so we can get the best results possible, of course. And for the post-survey, we're gonna be asking questions as to how the participants, if they like the movie, for example, and we're gonna be adding different parts to it. We want to try something new this time by adding memory to it, but we're working on it. And this is a quick glance for the 2 clips that we want to show, the horror and the comedy.
And our goals right now are having a holistic approach, so big picture towards what we can look for in our human body as brain and heart. And the previous project from last year was done by the PTK, which was based on sound and ASMR, but we want to use the visual sensory to use the EEG and the ECG. And we also have completed the IRB, the Institutional Review Board, which is we have to get it reviewed by the board and signed, which was completed, and the human subject protection certification, which allows us to test our human participants and do our research, which was also completed by all the other group members. And our future goals is to aid the future research on EEG and ECG, because there aren't many research done on that, because most researches are done only on EEG or ECG, but we combine them both. And we want to have experience setting up the experimental design, how to experience dealing with human participants, and experience the equipments used in this research. And our big future goal is to publish in the TriBeta and present at conferences such as MACUD, STEM-C Squared, and the TriBeta conference. Yeah.